Reciprocal sets of vectors. Suppose that A, B, C and A prime, B prime, C primes are two orthogonal sets of reciprocal vectors. We have to prove that A prime equals to B cross C upon A dot B cross C. B prime equals to C cross A upon A dot B cross C. And C prime equals to A cross B upon A dot B cross C. We know that if A, B, C and A prime, B prime, C primes are two sets of reciprocal vectors, then A dot A prime equals to 1, B dot B prime equals to 1, C dot C prime equals to 1, and A dot B prime equals to A dot C prime equals to 0. Similarly, B dot A prime equals to B dot C prime equals to 0, and C dot A prime equals to C dot B prime equals to 0. Now as B dot A prime equals to 0, so A prime is perpendicular to B. Similarly, as C dot A prime equals to 0, so A prime is perpendicular to C. So we get A prime is perpendicular to both B and C vectors. This is what we have got before. We know that B cross C is a vector perpendicular to both B and C vectors. Here is B vector, here is C vector, and B cross C is perpendicular to both B and C vectors. Now as A prime vector is perpendicular to B vector and A prime vector is perpendicular to C vector, that is, A prime is perpendicular to both B and C vectors, and B cross C is also perpendicular to both B and C vectors. Then it is clear that A prime is in the direction of B cross C vector. So we can say A prime vector is equals to some constant multiplied with B cross C vector. That is, A prime vector equals to K into B cross C vector, where K is some constant. Now we have A prime equals to K into B cross C and A dot A prime equals to 1. We have taken equation 1 from here and equation 2 from here. Placing A prime from equation 1 into equation 2, we get A dot K into B cross C equals to 1. Therefore, K into A dot B cross C equals to 1. So, K equals to 1 upon A dot B cross C. So finally, placing value of K in equation 1, we get A prime equals to B cross C upon A dot B cross C. So we have proved the first part of our problem, that is, A prime equals to B cross C upon A dot B cross C. In a similar way, we can prove the relation for B prime vector and for C prime vector, where we have to use the property of reciprocal sets of vector as has been shown here. Now you may have questioned that why these sets are called reciprocal system of vectors. See here, we have got before that A prime is in the direction of B cross C. And as ABC is an orthogonal set of vectors, so A is perpendicular to B and A is perpendicular to C. Here is the diagram where A is perpendicular to both B and C. Again, A prime is equals to B cross C upon A dot B cross C for reciprocal system of vectors. So here A prime is perpendicular to B and A prime is perpendicular to C. Therefore, A and A prime are in the same direction. For reciprocal sets we have A dot A prime equals to 1. Therefore, A prime cos 0 equals to 1. So A prime equals to 1 upon A. As here the magnitude of A prime is the reciprocal of the magnitude of A and vice versa. That's why these are called reciprocal vectors. Note that A and A prime has same direction and reciprocal to each other in magnitude. Similar result we shall get for B prime vectors and C prime vectors. So reciprocal vectors are those which are reciprocal to each other in magnitude and have same direction. As ABC and A prime B prime C prime, these two sets of vectors form a system of vectors and the corresponding terms are reciprocal in magnitude. That's why these sets of vectors are called reciprocal system of vectors. Diagrammatically, this can be shown as below. This is a set of vectors ABC. For better understanding, suppose ABC all have magnitude greater than 1 and A greater than B greater than C. So, for the reciprocal set of vectors, magnitudes of each vectors will be less than 1 and A prime less than B prime less than C prime as A greater than B greater than C. So, the diagram of the reciprocal sets of vectors A prime, B prime, C prime corresponding to the set of vectors A, B, C can be drawn as has been shown below. This is all for this topic and thanks to all for watching.